Did you know that the first brushless DC motor was introduced way back in 1962? It's true. And today, brushless DC motors can be found in so many different applications. Why? Because they are awesome. And because they don't contain any brushes, can have low EMI, and are very efficient. But I hear you loud and clear, my loyal Chalk Talk audience. But isn't designing brushless DC motors complicated? Well, my friends, it doesn't have to be. Hi, I'm Amelia Dalton, host of Chalk Talk. In this episode of Chalk Talk, we are investigating how we can accelerate brushless DC innovation without complexity. Ryan Scott from Qorvo joins me to discuss the trends behind the adoption of brushless DC motors, the challenges inherent in their design, and how Qorvo can help you streamline the journey from concept to production for your next brushless DC motor design. And before we get started, don't forget to click that link. There you can find even more information about this topic from Qorvo.
Hi, Ryan. Thank you so much for joining me.
Thank you. Nice to be here.
Excellent. Okay, so Ryan, we're talking about how we can accelerate BLDC innovation without complexity today. So, Ryan, first, why do you think there is a trend toward BLDCs these days?
Well, the key thing is that they give consumers a better product. Brushless DC motors are more powerful, they're smaller, they're more efficient. So at the end of the day, consumers can get a product with an enhanced user experience. It's going to come off the shelves, and so it's more and more a trend that's helping in a lot of ways, both in terms of energy and consumer preferences.
Okay, so what kind of applications would you find these kinds of motors? And I would imagine that a lot of different designs include BLDCs these days.
Well, more and more so. There used to be applications where it was typically only AC induction motors, universal motors. But as different countries have had increased regulations for preserving energy efficiency and things like that, there's a whole movement, more or less, to create appliances and portable tools and products that can be used more efficiently. And again, that's where the brushless DC motors come into play by providing more of that energy efficiency, like more power per size, volume, all these types of things.
That makes sense. So, Ryan, what about high power brushless DC motors? What kind of applications would they be a good fit for?
Definitely, when we talk about the benefits of the smaller, lower power, if you will, we're talking about the portability and things like that. But what we've learned is those things can be in the hundreds of watts or whatnot. But what we're starting to see more and more so is as battery technology is improving, designers of products are able to go to higher voltages. And in doing so, they can go to higher power. They can go to things that are in the kilowatt, 2 kilowatt, 3 kilowatt, and higher power ratings. And this starts to replace some of the spaces that were held by internal combustion engines before, small engines. And so, if you can deliver the same power and do it without the exhaust fumes, without the pollution, and start to go after applications that were previously held by these internal combustion engines, you can just do it more cleaner and more efficiently. So we start to see this in areas like e-mobility. We start to see it in high voltage industrial like lawn tractors. And we're starting to see the same idea take place with the automotive industry as they start to migrate towards 48-volt systems.
So, Ryan, what do you think is really holding back the adoption of brushless DCs?
Well, I think a lot of it has to do with awareness of consumers. I think as consumers are able to experience the benefits of these types of motors and be made aware of that, then they start to say, no, I must have that type of performance. So definitely, I think that's one of it. But from the engineering side of things, come with some additional complications. It's a little more complicated to control with electronics. They can be higher cost. So these things, along with maybe not a strong enough perceived demand from an end consumer, it might cause hesitation for a customer. They might say, well, maybe now's not the right time. We'll consider it for the next products, this type of thing. But ultimately, the idea is we want to work with our customers so that we can offer them ease of use solutions to kind of take out some of the design work that they would have to do and make it simpler for them.
Okay, so getting back to the theme of our Chalk Talk today, how do you think we can speed up BLDC innovation without all that complexity?
Well, Qorvo has actually introduced several different approaches to help solve this exact problem. One of the first one is QSpice, which is a simulation tool that we've put out on the market. We can talk about that. This allows designers to simulate in advance with brushless DC models that they have, different circuits that they want to test out. We have devices such as the ACT 72350, which offer a high level of integration to drive ultimately the motor that you're using. And all these things can work together so that customers can have a faster design cycle, be focused on delivering iterative improvements to their designs, and basically just keeping their overall motor control optimal for their application.
Okay, so tell us how QSpice fits into this design journey.
Okay, well, QSpice is our key simulator. It's an updated version of Spice models that are out there. It's improved accuracy from before. The performance of the Spice models have been improved. I think one of the key things is the continuity between the IV curves that are rendered. It has top-notch graphics. It also includes a model generator, which is just fantastic. So instead of waiting for a manufacturer to deliver a model of their new device for you, you can take a basic preliminary data sheet and get moving with a model generator very quickly.
So, we've been hearing a lot about QSpice here at EE Journal. So, what's in this latest creation?
Well, what QSpice will do is it'll basically use like a parameter extraction algorithm, and it'll fit an internal equation to set those entries. So it basically will generate that model for you based off of finding the correct match. And that's going to help a lot with the behavior, accurate modeling of the behavior of the device. And at the end of the day, it's going to be fast. It's very straightforward to download. It's free for commercial and private use.
Okay, so back to BLDC motors. Are there models available in QSpice?
Well, yes, there are. Because it's an open system, we have had some users that have actually developed their own BLDC models of the entire brushless DC motor system itself. Now, if you take that and combine it with the models that we've built that are specific to the ACT 72350, which is our integrated gate driver device, that can also be used with this motor model that's been developed to help customers kind of simulate their own environment, help them understand how the gate drivers can be used to control the motor, meet the performance requirements, and simulate it in advance of building the hardware. So it's really a neat feature that we have and a great way to kind of take some of the guesswork out of the engineering design up front to make it simpler for users.
Fantastic. Okay, so let's circle back to BLDC innovation. How can Qorvo help streamline my design process?
Well, really, it's about pulling all of these types of elements together. So, ensuring that we've got a great simulation environment that can be used, that's open and flexible. At the same time, making sure we have hardware devices that are the same. They're available, they can be modeled inside of the simulation package itself. So, pulling all those elements together is really the key.
So, what kind of solutions does Qorvo offer for brushless DC motor control?
So we offer two types of products. We offer the motor drive analog front end devices. It has the gate driver in it, which basically drives the gates of the inverters for the MOSFETs. It also has power management devices built on board, and it has signal conditioning. So those are in one type of product that we call a motor drive AFE. And that's accompanied by our power application controllers, which have that analog front end device combined with a 32-bit microcontroller, either an M0, an M4F.
Okay, so tell me more about that motor drive AFE you mentioned.
Okay, great. These are really exciting devices because they don't have the microcontroller in them. And we've often run into that where customers, they have a discrete design where they have a microcontroller that might be handling a great deal of system level responsibilities in addition to the motor control. So with that type of segmentation, they would like an architecture where they keep their same original microcontroller, but yet they would like to have the gate drivers, power management, signal conditioning, have those other things built into another chip. Those are kind of like what we would say all of the important parts of that circuitry that need to be pulled together to make it a really responsive motor control design. So this particular device, this analog front end, the ACT 72350, it does just that. It does a lot of integration by pulling in this power manager, some safety features. It has this CAFE, which stands for configurable analog front end. And this, we can talk about how that can be customizable to sense different types of inputs. And then, of course, the key thing for high power, it has to have a very wide input voltage range, where this is 25 volts all the way up to 160 volt. So this can accommodate battery sizes up to 100 volts, which covers a lot of different applications like we spoke before.
So, talk to me more about the benefits of this solution.
Well, the first thing is that by pulling in some of these different components is you reduce the number of BOM components. We had one customer told us that their previous solution, they were able to remove up to 40 components off of their previous design that we have. So this allowed them to make their design very, very small and basically shrink the PCB so that in this case, it could fit inside of a very small roller motor. So the first thing is the size. It really shrinks it through that way. Another key topic is the reliability. This is built on a silicon on insulator or an SOI technology, which is very robust against transients. And when we're talking high power gate driver design, you really want to ensure that you don't have any type of parasitics on the gate drive circuit or anything that could be detrimental to just having clean signals and good responsive motor control. So just the technology alone here and the reliability to stop, latch up, is very important to users in these high power applications. Of course, as I mentioned, the simplicity of it all, having it in one device, you basically have to go like in the sense of signal conditioning is a good example. You go and you configure the device, you configure the gain on the gain amplifiers as opposed to replacing them until you get the better solution. So basically, it makes it easier for customers to put together a brushless DC design quickly and pulls in a lot of those very critical functions all into the single device. And as I mentioned, it is configurable once you get it there and you can support various types of control. So this is just a breakdown of the device, and this does kind of offer some all-in-one type solutions. The power management is completely integrated. It has bootstrap diodes that are integrated into the device. Our cafe offers you the ability to select different sensor types of configurations. There are differential programmable amplifiers as well as single-ended. So that helps depending on the type of current or voltage sensing schemes that you'd like to employ. The silicon on insulator technology is kind of a robust technology to help avoid any kind of latch up, especially in a high power system. Some of the key building blocks of the device that we can move into or cover a little closer, the key elements of the gate drivers themselves, these are basically go all the way up to 2 amps source or sink current. So that's a very strong gate driver. It can be used to drive even MOSFETs in parallel. The bootstrap diodes are integrated, so these don't need to be added externally, and this can help reduce the bill of materials. Within our power manager, we have different features that help with power on resetting or fault handling. And this is one of the key aspects of the driver that helps implement any type of safety aspects that an end user might want to do so that the device can shut down and then start back up in a safe way that it's kind of predetermined and expected by the end users. some of the analog capabilities that it has in terms of gain amplifiers, integrated comparators, or DACs as well, along with a lot of configurable I/O that can be used.
Okay, so can you also talk about the application specific gate drivers as well?
That's right. When different types of motors at different power levels with the gate drivers, the fundamental principles kind of stay the same, but there needs to be different concern taken, particularly with regards to good fault handling. These are very strong drivers, so you can avoid latch up and you have ensured clean switching and this type of thing, which is great for long life inverter behaviors. Of course, when you have a strong sourcing current, that helps you avoid this crossover area for MOSFET where they're losing a lot of energy. So it's a clean signal that'll help keep the inverter efficient. But as I mentioned, the safety of it is really key. When you combine it with overcurrent protection, which uses kind of cycle by cycle current limiting. So if there's an overcurrent situation, then the device will shut down so that the currents are recycled through the motor in a safe manner to basically happen quickly to avoid shoot throughs. So there's definitely some safety features that are built into the solid gate driver performance as well. And all these kind of combine together for clean operation and enhancing the safety and reliability of the system.
Okay, so fail safe braking is an important aspect of BLDC designs. So, how can this solution help me here?
A lot of our customers, part of their safety certifications that they obtain, have to include provisions for fail safe braking. How are you able to either stop the motor from turning or to stop applying power? We have a feature called in brake. A key aspect is that it provides a redundant brake control path. So it can be invoked so that we can either break the motor or we can deassert the signal so that it will run out essentially. And we exit the break it mode. And that basically would be a drive disable as we would do this. Our customers typically in these cases, they are asked to have a redundant controller that's external. So in this case, this feature gives that external controller direct access to the device for a hardware interrupt. And so it helps provide that overall system level redundancy for our customers.
Okay, so talk to me about the power management aspect of this solution as well.
Now, the power management, this is always the best part. And you know it's the best part when you don't know about it because it's taking care of everything in the background. These power managers are very efficient power managers. As you can tell, it's typically a system setup. This one is driven first off by a high voltage buck DC to DC, which again has this very wide range from 25 volts to 160 volts. And this has an external MOSFET, which is also used in it. All the other supplies, the internal LDOs for the internal, like the gate drivers that we just talked about, the cafe that we will speak of, all of those different subunits, they're all powered internally. There's also a power option here that can power the external MCU. So your standard MCU that you have with a 1.8 volt rail, we can also power that with this power manager that we have. Ultimately, things are best when they're quiet and consuming very little energy, which this one is made with an ultra low power consumption of 19 microamps at 56 volts and a standby. So, a great aspect of our device. These are things that customers would have to design themselves, to tune themselves. This is something that comes already pre-configured in our device. You can use the simulation software to further fine tune it. We talked about this external MOSFET. That's a great way to go use the QSpice tool to show how these power rails come up and show how they interact with the rest of the motor control system.
So, what about signal conditioning for precise control? What does that look like here?
Well, this really brings it home. And to be frank, this is what separates the solution we've been describing, in addition to the hardware perspective, in addition to the software. But here on the hardware side, having all this signal conditioning built into the device is really what differentiates this encompassing solution from what's out in the marketplace, from its competitors. So, this signal conditioning is to pull in and read the different signals and monitor the rest of the system from the motor. In particular, what it's doing is it's measuring the current sensing by using programmable gain amplifiers. It has 3 differential ones. It also has 4 single ended gain amplifiers for monitoring high impedance signals that may be digital, like a Hall input or something like that. In this case, we have a really great feature of basically on the integrated comparators of a feature that we basically call a virtual center tap. So it's very common in 6-step commutation to use back EMF sensing where you're monitoring the back EMF on a floating phase. This allows you a virtual center tap so you don't have to go out and build that neutral network outside for that comparison to detect that zero crossing. So this is almost plug and play for that, and it's really just a great feature of the device. So that's just one of the many ways. It's a very flexible device. It can support those types of features along with many others, and they are all accessible via the SPY register settings.
Fantastic. Now, if my audience wants to get started, what kind of support does Qorvo offer for this solution?
Well, the QSpice is the best way to get going. That's a good way, as I mentioned before. It's already packed with good models of our devices. It's got good models of generated motors already. That's a good way to get going. We have for this particular device, the hardware, the ACT 72350. We do have an evaluation kit, which is available, which customers can order and again, take advantage of all of these features, work with the model generators inside of QSpice, and really just start designing the best product that they can make. Well, I do appreciate you taking the time to go with me on this journey. As I said, some of this can be daunting at the beginning. There's a lot of different things that engineers have to work through that can be time consuming. Our QSpice really made to be open, available, accessible to speed things along. You don't have to wait on new models. Our model generator can get you going quickly just by putting in general data sheet parameters, and it does a great job with generating those, which can be applied then to our hardware like the ACT 72350, which pulls in all the hardware components and maintains configurability with a SPY interface so that all of the great ideas that you went through in your SPY simulation, you can apply those now through your SPY interface to the 3-phase gate driver and drive your BLDC motor to meet the needs of your application. And hopefully it's a standout in the market.
Fantastic. All right. Well, what would you like my audience to take away from today's Chalk Talk?
That Qorvo is really dedicated to providing solutions to help them streamline their productivity. Our new QSpice is just a phenomenal new tool that specializes in mixed signal simulation. Model generation really speeds things along, and it's available for everyone to use. We've got analog front end devices made for brushless DC motor control, like the ACT 72350, that gives robust gate driving, superb power management, excellent signal conditioning, and just pulls it all into an all-in-one solution for battery-powered BLDC applications. And finally, all of these combined, we really want to work with our customers to allow them to be as fast as possible and accelerate their designs.
Fantastic. Well, Ryan, I think that's all I have time for today. Thank you so much for joining me.
Thank you, Amelia.
And before we go, you didn't forget to click that link, did you? There you can find even more information about this topic from Qorvo. For Chalk Talks, I'm Amelia Dalton from eejournal.com. For more Chalk Talks, head on over to the Chalk Talk section of EE Journal. You can't miss it, it's right across the top. Or head on over to YouTube, youtube.com/EE Journal.